Hi all. So today we are covering chapter 13.4, solving the quadratic equation using the quadratic formula. Your homework today is 13.4, page 593, number 1 through 52 odd. Some new vocabulary for the day is discriminant, the quadratic formula, standard form, and I'm not sure why I'm not seeing what I displayed. And the quadratic formula, here's the formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. Tomorrow night's homework, I'm going to ask that you go and take a test in ALEKS. I don't really care what you get on it. It is a completion grade that you complete the exam. I want it to be as authentic as possible. And so tomorrow's homework will be going into the ALEKS program. You're going to have to go into the McGraw-Hill, and then you're going to click on ALEKS, and I'll try and work that out with a student today so that you can see, and we'll make a recording on what you do. Okay? So let's get started. And there will be no Zoom session tomorrow. Okay, so basically the quadratic equation is an equation, and it goes like this. It's a formula, sorry. And we use the quadratic equation with the quadratic formula. This is just one method. So here's the equation, and here's the formula. Okay, so basically what we have to do is figure out what our a, b, and c are in the actual quadratic equation. So in this case, remember anything that comes before x squared is your a, anything becomes before x to the first is your b, and negative 3, the constant, is always your c. So we first have to identify, and I do expect you to write that. And then we just substitute it into the formula. So I'm doing negative 5 plus or minus the square root of 5 squared minus 4 times 2 times negative 3 all over 2 times 2. Now, here's where you got to be careful and make sure you are using your order of operations. Remember, we do exponents first, then multiplication, or we do parentheses first. But these parentheses are not representing a group. So in our GEMDAS, it's really grouping symbols, parentheses, not multiplication parentheses. So here we have multiplication. So we're going to do our 5 squared first. So I have negative 5 plus or minus, I'll write it, negative 5 plus or minus the square root of 25. Now I can do my multiplication. Now you're going to multiply all three. It's a negative times a positive times a negative. So that's going to make it a positive. 4 times 2 is 8, times 3 is 24. But remember, it's a negative times a negative, so it's a positive. 24 all over 4, right? And then we simplify under the radical next. So that's going to be 25 plus 24. I do not want you doing extended. I want you to work up and down. I don't have room for it here, but remember, I don't want you to do an extended. I want to see it right underneath the way I was writing it. Negative 5 plus or minus 49 over 4. So that really becomes negative 5 plus or minus 7 over 4. And so that becomes negative 5 plus 7 divided by 4, and negative 5 minus 7. So the first one we're going to get 2 over 4, which is 1/2, and the next one we'll get negative 12 over 4, which is negative 3. Right? So our solutions are 1/2 and negative 3. Very easy. This is something that will always work, this and completing the square. The only problem is when you get big numbers, it can become very difficult. And if your order of operations are not very good, then that too can be difficult. All right, so I'm going to just take a quick little review, and I want to complete the square. This time we have no numbers. So what's the first step we do? We subtract our c. Right? Make room for our perfect square trinomial. Next thing we have to do is divide all terms by a. Actually, I want you to pause the recording and I want you to finish this on your own and see what you can do. All right, let's check it. So the next step was dividing all terms by a, right? So now what we have is x squared plus b over ax equals negative c over a. Now, the way we get that last number, remember we have to take that b over a, whatever's here, and we have to divide it by 2. And then we're going to square it. Okay, so isn't that the same thing as b over a times 1/2 multiplied by the reciprocal? Let me take a step back. Divided by 2, right? Which we don't divide fractions, we really multiply by the reciprocal. But remember, we then have to square it. So it's b over 2a squared becomes b squared over 4a. So that's what I'm adding. I'm adding b squared over 4a plus b squared over 4a. Okay? Pause that if you want. Okay, now I'm going to just flip this right side around, so I'm going to have that b squared first so I don't start with the negative, right? And then over here, that's all I did was I flipped the b squared over 4a squared, wrote that first, and the minus c over a. Now we are ready for our perfect square trinomial. We can factor this on the left. And what is the root of x squared? It's an x. What's the root of b squared? You know, it's got to be a plus. It's going to be a b. What's the root of... It's 2a, right? And that whole thing is squared, okay? Now over here, I'm going to need a common denominator, so I'm going to multiply by a 4a over 4a. And so now we end up with b squared minus 4ac, and isn't it all over 4a squared? Okay, now we're going to root both sides. I'm going to go back to my PowerPoint because it's cleaner. So now we've got it all over b squared minus 4ac. Now I'm going to root both sides. Okay, and now on the left side we're going to get the absolute value of x plus b over 2a is equal to the top. The numerator is not a perfect square, but the denominator is. So I'm going to separate those. And in the denominator, we're going to get 2a squared, right? So we're pretty close. We've got to get that x alone. And now I'm going to subtract b over 2a from both sides. And what do we have, my friends? X equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. But can't we just write that as x equals negative b plus or minus the square root b squared minus 4ac all over 2a. All right, my friends, that is the quadratic formula. And where do we get it from? We get it. We derive the quadratic formula by completing the square to the standard formula. And that's the song that I teach you. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. All right. So let's try it. Identify your a, b, and c. And then pause the recording, and try this one on your own. Okay? So my a is 3, my negative 4 is b, my c is negative 1. Go. Now let's check our work. Okay, so I'm substituting in. Remember there's a negative in the formula, but there's also a negative for the b. So I always write them both out. You're substituting in. You should have simplified to 16 minus 12, plus 12. Sorry, because there's two negatives there. That makes 28. Now, when you are solving these, I want reduced radicals. reduced radicals. Unless it's a word problem. Now, this is not a reduced radical because there is an even number we can divide out of all three parts. I can take a 2 out of there, I'm left with 1, a 2 out of there. And only if all three can be reduced do you get to cross cancel like this. Okay, and so we end up with 2 plus or minus rad 7 all over 3. So that's if and only if there is a common factor in all three terms can you reduce it more. Another way they did it, they factored the numerator and then they cross-canceled. But I kind of just do it right here, divide a 2 out, I'm left with 1, 2, and 3. It goes through all, if it divides out of all three parts. Okay, so this means 2 plus rad 7 over 3. You don't need to write it like this. You can write it the way we circled it. But there are two solutions. Now, if I did ask you to estimate, but for tonight, I think I'd like you all giving me reduced radicals. Unless they say, please estimate. Let's see, I think number 29 on is asking you to estimate. So if they estimate, we're finding the square root of 7. So you can use your calculator or you can estimate. The square root function of 7 is 2.64, so, or 2.65, so it's 2 plus 2.65. You're doing 2 plus 2.65 divided by 3. That makes 4.65 divided by 3. And I get about 1.55. Now I've cut off a lot of decimals over here. And then I'm doing 2 minus 2.65 all over 3. And then we're going to divide it by 3. And I get about negative 22 hundredths, negative 22 hundredths. And there we go. And those are your solutions. Now, that's only if it asks you to round to the nearest, they're saying the hundredth, okay? Do you estimate? Otherwise, you leave it in this reduced radical form here. All right, so find the x-intercepts. And by the way, when we solve this quadratic formula, what you're finding are the x-intercepts. The x-intercepts, right? That's where it's crossing at 1.55 and at negative 22 hundredths. All right, so let's pause the recording and try it again. All right, let's check our work. My A is negative 1, my B is 5, and my C is 2. All right, let's continue. So I'm substituting in negative 5 plus or minus 5 squared minus 4 times negative 1 times 2 all over 2 times negative 1. So we get negative 5 plus or minus. Now this is how I want you to work, vertically. Plus or minus 25 plus 8 over negative 2. So 25 plus 8 is 33. And they're asking us to round to the nearest tenth. So I'm going to root that rad 33. And so when I find the square root, second square root 33, it's going to be less than 6. So I would say 5.7, 5.8. 5.7 was a good guess. It's 5.74. So negative 5 plus or minus 5.7 over negative 2. And then I've got negative 5. All right, so I'm doing negative 5 plus 5.7 divided by negative 2. Okay. And we get 0.7 divided by 2 simplifies to about negative 4/10. And this makes negative 10.7 divided by 2 is about 5.4. But remember, I think up to 29, they're having you reduce your radicals. Reduced radicals would be like this. Estimated would be like this. So you have to be able to do both. All right, it's not in standard form. And by the way, I'm going to remind you, let's go back to standard form. Is x squared plus x plus a number. Ax squared plus bx plus c. Okay, now if you have 5x squared plus 2, that means there's no x to the first power, so your b is going to be 0. And your c is 2, and your a is 5. So just know that your b is 0 in this case. That's what makes the x disappear. So before we can do our quadratic formula, we have to put it in standard form. Subtract 7 from both sides. Now I can find my a is 1, my b is 3, and my c is -7. Okay, so I'm doing 9 plus 28 over 2. If they don't tell me to estimate it, I'm going to leave it in reduced radical form. So 9 and 28 is 37. So it's -3 plus or minus 37 over 2. Of course, my PowerPoint's going to estimate it out. Oh, good, they're not. Okay, so I would have left it. I would have just left it like this. This is a very good. And again, remember, what we're finding are where these cross the x-axis. That's you're basically finding your roots or your x-intercepts. That's what we find when we're solving the quadratic formula. If we are to estimate, here's what it's going to look like. Okay. And, yeah. Okay, so here we go. Sorry. Okay, using the discriminant. Okay, the discriminant is a certain part of the quadratic formula. That is this portion. All right, so the discriminant is a certain portion of the quadratic formula. And we use our discriminant. We can basically tell you how many roots there are going to be once you plug it in and we look at just the discriminant, okay? So this portion, the b squared minus 4ac, that is called the discriminant. So it's under the radical. You don't write it with the radical because the discriminant is just b squared minus 4ac. If the value of that number, if it is greater than 0, if the value is greater than 0, that means you're going to have 2 x-intercepts or 2 real roots. If that number is equal to 0, that means you will have 1 root. And if that number is less than 0, basically a negative number, if b squared minus 4ac is a negative number, because remember in this case, if it's negative, right, you're going to have a negative under the radical, and we would say no real root. Now in this case, this is how it's going to look. It's going to cross and have 2 real roots. When this is positive, greater than 0, right? When this whole chunk is equal to 0, it's going to be sitting. It's going to be a perfect square trinomial. And it'll be sitting, and you'll have only 1 root. And when you have something like this, and it's negative under the radical, that means it's floating up here, and it never really crosses. Okay, so our discriminant really tells us a lot. It tells us how many solutions. Okay, determine the number of roots for the quadratic equation. So we have to figure out our a, b, and c. And we can just substitute that in for b squared minus 4ac. So 5 squared minus 4 times 2 times 3, that's 25 minus 24 equals 1. Since that number is greater than 0, it means I have 2 real roots. 2 real roots. Because when you're doing that quadratic formula, x equals negative b plus or minus the square root, all this in here, it's a positive number. It means you have 2 x-intercepts, or 2 real roots. Okay? So in that case, we have 2, since it's greater than 0, it's 2 real solutions. Okay, pause the recording, and I want you guys to try the next one. Go. Determine the number of x-intercepts. Notice the language they're saying. All right, let's check. So I'm going to find my, and I'm doing b is 4. And so notice right here we're going to have 16, and that's going to be a negative 28. That means my number is negative 12. That would be under, remember, we're back under, it's this point, it would be a negative 12 in that quadratic formula. So we have no real roots. Should have gotten no real roots. Okay, let's try another. Go. Now check your work. Doing my discriminant. Becomes 36 minus 36 equals 0. And when it's equal to 0, that means there's one real solution. Perfect square trinomials have Dale. Okay, so now let's match each equation with its graph. We don't have to factor this. We don't have to graph this and find our vertex and everything like that. All we have to do is find the discriminant, because we know that if it has two real roots, it has to equal a number greater than 0. If it has one real root, like this, it has to equal 0. And if it has no real roots, it would equal a negative. So here we go. Let's find our discriminant. On number 1, I'm doing, my a is negative 1, 2, negative 1, and 1. Right? So I'm substituting in my b squared. Negative 1 squared is 1 minus 8, and that makes negative 7. So which graph goes best with it? That would be b, because there are no real roots. Number 2, I'm doing b squared minus 4ac, so I'm doing, it ends up being 1 plus 8. This is a number greater than 0, so this means two real roots, and so that would be graph C. And then the last one is b squared minus 4ac. When I substitute in, it equals 0, so that would have to be A. Okay, this is something else we can use the discriminant for. It says tell whether the vertex lies above, below, or on the x-axis. So again, we know it opens up because the starting quantity is positive. Now, I'm going to have, the b squared minus 4ac, so now we're going to end up with use our discriminant, substitute in. And so if this is opening up, right, we're drawing this out, and I end up with a negative number, how many roots? We're going to have 0. It's going to be, and that means it's going to be above the x-axis. And so the question is, tell whether the vertex lies above, below, or on the x-axis. Since it's not crossing and it opens up, it has to be above the x-axis, so the vertex is above the x-axis. Okay? Pause the recording and try the next one on your own. Now let's check our work. We know it opens down because it's negative. 5 squared. I end up with a number greater than, so that means we have two real roots. So that means I'm going to draw it out. Okay, we know it opens down, but it has to have two real roots. So that means the vertex has to lie above the x-axis also. Okay? So that, my friends, is the end of our quadratic story. We've got a couple more lessons, and then we will get into exponential functions. Okay, the end of the quadratic story. So here we go. That's it.